Hey guys, it's Miss Miklos. Today we're going to be talking about properties of addition and multiplication, and specifically we're going to be talking about sets of numbers, and those are going to be terms that we're going to use a lot this year. And also we're going to talk about some properties that we're going to apply in our next lesson. So if you haven't already, please go to MyOlu, and there is this note handout available, and you can either print it out and write on it if you're watching this on your iPad, or you can go ahead and download it on your iPad if you're watching this on your computer at home. Okay, so our first set of numbers for the day is natural numbers. Natural numbers we call our counting numbers. So examples of that would be like 1, 2, 3, and so on. Our next set of numbers we call whole numbers, and whole numbers are really just building on our natural numbers, where it is our counting numbers plus the number 0. So it starts at 0, 1, 2, 3, and so on. It's not super important you guys know the letters that represent this set. I care way more that you understand what this set of numbers actually is. Our next set of numbers is really important. This is something we use a lot. These are our integers. Integers, we use the letter J to represent that. And integers are our positive and negative whole numbers. So once again, we're just adding a little bit onto our set. This time, 0, 1, 2, 3, and so forth are still in the set, but we're adding to the left. So we're adding negative 1, negative 2, negative 3, negative 4. Our fourth set of numbers we call our rational numbers. We use a Q to represent this, and this is really our only one that has a fancy definition. It is any real number that can be written as a fraction of integers. So I think fractions right away are the easiest ones for us to think of. Like I've written down 1/2 as an example. But something like 3 is also a good example because we can write that as 3 over 1. I've also written down negative 0.75 because we can turn that into a fraction and make it be negative 3 over 4. When we're dealing with decimals, the two things that we need to know, it is rational if the numbers either terminate, so that means if they end, for example, 3/4, okay, at 0.75 ends, or if they repeat, so 1 over 3 actually is 0.3 repeating, and we write that as a fraction. So if they don't terminate or repeat, we call those irrational numbers. An irrational number is any real number that cannot be written as a fraction of integers. And this is kind of the weird group, I guess, in this set of numbers because the rest are all really connected. And irrational numbers and rational numbers combine to make up all the real numbers, but there's no overlap between the two of them. It is any real number that cannot be written as a fraction of integers, or if it's written as a decimal, irrational numbers continue endlessly without repeating. And we don't run into these a ton, but the two most common ones we'll see are things like radical 2. If you guys put in the square root of 2 into your calculators, you would notice that you get this decimal, and it seems like it ends because your calculator is going to round it for you, but in actuality, it just continues. The numbers go on and on and on. They don't repeat. And hands down, the most famous irrational number is pi. We will also talk about real numbers. Real numbers, we use this fancy like script R to represent real numbers. And right now, we're just going to define that as any number you've learned up to this point. We are going to learn about imaginary numbers later on in this course, but right now, real numbers, any number you guys have learned. So that's really all of the sets of numbers.